Hello and welcome to Technical Utkranti, and today we are going to see another question on linked lists. So this question is about rotating the linked list right by k positions. Let's first look at the thought for the day. These are the questions that we have done in the linked list, and let's look at the question. We are given a linked list like this, and we need to rotate it by k positions. So if k is 2, then a rotating right by 2 would mean that 4 and 5 comes here in the same order, and 1, 2, 3 shifts right. Let's look at the approach. For every linked list, we have a head and a tail. Head points to the first node in the linked list, and tail points to the last node in the linked list. First challenge is how to rotate. We join head and tail like this, and this becomes a complete circular linked list, right? Now it could be rotated. For k equal to 2, we shift head and tail twice. So if head was here, shifting it right makes it come over here. And similarly, when tail is here, shifting it right by 2 comes over here. Tail comes here. Then we just break the link between the tail and head. That's how linked list is, right? There is no link between the tail and the head. Tail points to the last node and head points to the first node. So we break the linked list with this command. And the rotated linked list looks like this. But wait, the original linked list was this. We rotated by 2 times and it became like this, right? This is left rotation. This is not right rotation, correct? Because we can only move head and tail towards right, which means that linked list actually gets shifted to left, right? Like if 3, 4, 5 were here previously and they have come over here, it looks like it has shifted left. Okay. So what we can see? We can see that it is shifted left by 2, the original linked list shifted left by 2, or it is right shifted by 3. So if 1, 2 have come over here, we can also say that the original linked list has right shifted by 3, or the other way around, we can say that 3, 4, 5 has shifted left. So the original linked list is left shifted by 2, right? So number of right shifts is equal to length of linked list minus number of left shifts. And as we are able to do left shifts, we can say that if we have to do these many number of right shift, then length of linked list minus the number of right shifts is the number of left shifts we have to do. So in this case, as we have to shift right by 2, we'll shift left by 3. So if this is the original linked list, then shifting left by 3 would mean that 1, 2, 3 will come over here by shifting left, and 4, 5 will come here. And this also means shifting right by 2, as 4 shifted right by 2 comes over here, 5 shifted right by 2 comes over here, and so on. I hope it makes sense. Now let's jump and look at the code implementation. So what I'm doing over here is I'm taking the first node, and with the help of the while loop, I'm identifying the length of the linked list. K is the number of right shifts we have to do. Okay. So if the length of the linked list is 0, we don't need to carry out any further operation and just return from there. Then we find number of left shifts. So number of left shifts is equals to length of linked list minus number of right shifts. Then we just join the linked list to create a circular linked list. And then for k many times, we just shift the head and the tail. And at the end, we just break the link between the shifted tail and the shifted head. And that's it. So I have created linked list over here. and I'm printing it before the right rotation and printing it after the right rotation. So let's just do the rotation by one and see what happens. So as you can see, original linked list was 1, 2, 3, 4, 5, and after shifting right by 1, I get 1, 2, 3, 4, and 5 over here, right? So I hope you liked the question, the approach, and the Python implementation of it. If you did like, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.